Hello, everyone. Welcome to this DigitalOcean Tech Talk. This talk is entitled Practical Kubernetes Networking, How to Use Your Kubernetes Services, or How to Use Kubernetes Services to Expose Your App. It is September 22nd, 2021. It's the first day of fall in the Northern Hemisphere, so I'm enjoying the change of seasons. I hope you are too. So my name is Kim Schlesinger. I'm a developer advocate here at DigitalOcean. I focus on cloud native technologies, especially Kubernetes. I've been with DigitalOcean for maybe 4 or 5 months. Before that, I was a site reliability engineer where I worked at a Kubernetes consulting firm where I set up a lot of Kubernetes clusters and worked with a lot of clients getting applications up and running in Kubernetes. And I'm excited to share some of that knowledge with you in this talk. And so if you are watching live and you have access to the chat, I'm just really curious who's here. So tell me, who are you? Where do you live? And what brought you to today's talk? So I'll start. I already gave an introduction. My name's Kim Schlesinger. I live in Denver, Colorado in the United States. And the reason that I prepared this talk today was that I have done some talks in the past about how to set up deployments, how to get applications up and running as pods in Kubernetes, but wanted to show how do you get those apps available on the internet so people can use them, and how do you get those things talking with one another in a cluster. So that's the networking part of the talk. Oh, got some people chiming in the chat. So it looks like we've got Lawrence from the Netherlands. Welcome. Oh yeah, we can show those off. Thank you. And then we've got Johnny from Germany. Welcome. Glad to have you here. We've got Brad from Memphis, Tennessee in the US. Wonderful. Ahmed from Egypt. Hello, welcome. Glad to have you here. Got Jimmy B from Cypress, Texas in the US. You want to increase the number of people in your geek crew. I think you're in the right spot. Oh, you want to increase your geek cred, I see. Well, either way. Oh my gosh, there's so many people. This is exciting. Okay, I'm going to go through and just call them out. So we've got, let's see. Ooh, okay, we've got Dimitri from Canada. You're interested in the DigitalOcean Kubernetes offering. I'll be showing that off. Chen Hai from China, welcome. Itopa from Nigeria. Oh, you're an AI engineer. Welcome. Glad to have you here. Let's see, Rushab from Kitchener, Canada. All right, we have a lot of Canadians here. Wonderful to have you. Leon from India. Hello. Technot from Bhutan. I think you've been at some cloud chats before. It's great to have you back. Mumtaz from Egypt. Hello. GK from Ontario, Canada. Oh, you need Kubernetes to scale. That's one thing that's very good for. So hope to show off some of that networking. Jerome from Manila, VMware guy. Very cool. Roberto from Dublin, Ireland. And I think we saw, maybe I said this already, but Surab from India and Ricardo from, holy cow, there's so many people here. I'm so impressed, from Mexico. I am not going to be able to list everybody off. There's so many people. This is wonderful, though. It's great to see you all. As you have questions, you're welcome to drop them in the chat during the talk. I will probably not be able to answer them in the moment, but I'll pause at the end of each section and address them. And it's really exciting to have so many people here, so many people that I can't even call you all out in the chat. So welcome, everyone. Excited to show you a little bit about Kubernetes networking. So if you're watching this live or you're watching this as a recording, if you'd like to follow along, this is what I'm using. First thing, I have version 1.21.3 of kubectl. That is the command line tool to interact with Kubernetes. And then I also have a running Kubernetes cluster for practice. I'm using DOKS, which is DigitalOcean's managed Kubernetes offering. You can use another cloud provider and either their managed offering or spin up a Kubernetes cluster on your own. In other talks, I've recommended using Kind. So if you don't have the money for it, or you don't want to use a cloud provider, you can play with Kubernetes that way. The reason I'm not recommending that for this talk is that I'm going to be showing off a load balancer from the cloud provider itself, and it's a lot harder to do that with Kind. And then just so you know, I'm using DigitalOcean Managed Kubernetes. I call it DOKS sometimes, and it's Kubernetes version 121.3. And then I'm going to be deploying some applications, and you can find those applications in this example repo. So if you go to github.com/do-community example K8's workloads, this has lots of example applications. I'm going to be showing off the example website and the API. So if you're following along, that's how you can do that. Oh, so many people. It's great. Welcome. All right. So the agenda for today's talk, I'm going to give a very brief introduction about what are services in Kubernetes. And then we're going to hop right into a demonstration. So I'm going to show you how to set up and use a Kubernetes load balancer service type. After that, I'll show you a Kubernetes ClusterIP it's not a load balancer, a ClusterIP service type demo. Then we'll talk about the actual definitions of these services and comparisons, and look at some service options that I didn't demonstrate. And then we'll do a recap. So if you're just joining, welcome. You can say your name, where you're from in the chat, maybe what brought you to this talk. And as I go through, if you have questions, feel free to ask them in chat. I will pause at the end of each section to address those. So the introduction. So a Kubernetes service allows you to access a pod without needing to know the pod's IP address. So if you've experimented with Kubernetes before, if you've deployed some pods, you know that each pod gets its own IP address, and you can access that within the cluster. You can't access it without the cluster. And the hard thing about that is pods are designed to spin up a lot and to be pulled down a lot, and so they are immutable. But a service is nice because it allows you to have something in front of a set of pods that changes. The service has a stable IP address or a DNS domain that you can access, and it allows you to access pods that come up and come down without having to worry about what's the specific address of the pod. So that's a really simple introduction. I struggled, and I still struggle sometimes with the definitions of Kubernetes resources because the language can be hard for me to understand. I think a lot of the language around Kubernetes services is having a logical set of pods and something in front of the pods that can accept traffic. And so instead of dwelling too much on the definition right now, let's actually just do a demonstration, and then hopefully with some concrete examples, we can go back to the definition and it will make more sense. So we're already on to the second part of the agenda, which is to do a demonstration of the Kubernetes load balancer type of service. And so I'm going to show off this thing I have called example website. And so what I'm going to do is I'm going to show you what the example website is and run it locally on my computer. Then we're going to deploy it as a set of pods in Kubernetes. And then we're going to access the pods via their IP address. And then we're going to set up a load balancer so that somebody else from the internet could access that website. Aaron from NYC, I see your question. Yes, we'll put a link to the GitHub repo in the chat. So that will be incoming in just a second. So, all right, example website. I want to show you what this is. So let me get out of presentation mode. So this is from the example Kubernetes workloads. And this is the example website. And I have this on my machine locally. And so let's change into the example website directory. And so this example website is a Node.js web server that serves up an HTML page that I wrote. And so to run it locally, if I run npm start, okay, it says example app is listening on port 3000. So if I go to localhost 3000, I have this Very silly, very simple web page. It says, "Hello, friends watching this DigitalOcean Tech Talk. Isn't this a cute capybara?" And then it's got the source for the photo. And so, again, a simple Node.js server that's serving up some HTML. Nothing fancy. I didn't use a front end framework to write this. So I've got this running locally, and now what I want to do is I want to deploy this application into my Kubernetes cluster. And so I gave you some examples of like the version numbers of Kubernetes that I'm using for this demo, but let's review that again. So if I say kube control get nodes, I have a Kubernetes cluster that is running 3 nodes, and you can see on the end here in this column that it's version 121.3 of Kubernetes. And if I say kube control get pods from every single namespace in Kubernetes, if we look at the first column, I am just running pods that are in the kube system namespace. And so this is a DigitalOcean managed Kubernetes cluster. All of these pods are part of the default setup for DigitalOcean Kubernetes. So these are all things that came pre-installed and are running when I spin up the cluster, and I'm not going to worry about them. I am, though, I'm going to say kube control get pods, and if you don't specify a namespace, it means the default namespace. I don't have any pods running in the default namespace. And so I want to get that application that I showed you, I want that in the default namespace. And so if I go back to the example website directory and I unfold that, I have a directory called kube manifests, and I have 2 YAML manifests here. One is the deployment and one is the service. In my example, the service is blank. In the GitHub repo, it's filled out for you. So let's just see what we're going to do. I'm going to create a deployment, and it's got a name of example website. I'm giving it this label, app is website. That'll become important when we're looking at the service. And I want to have 3 pods running of whatever thing I want. And so this is actually the website. And that capybara page, I've Dockerized it. I have made an image of it. I've pushed that image to a container registry, and I want to be able to pull that down here. So let me pause. All right, I see AN, you're asking, does anyone else have bad video quality? Let me know if anybody else does. I've been having some like choppy internet situations, and I have a different network I can try, but there would be some bumps there. Lawrence says it's working okay, so I'm just going to go forward. AN, if it's not working well, maybe watching the recording after would be helpful. So, all right, so my goal now is I want to deploy this set of 3 pods that are going to be running 3 replicas of this example website. And so I have this deployment YAML in this kube manifests directory. So I'm going to say kube control create from the file. Oh, I got to say the directory kube manifest deploy.yaml. So it says the deployment example website has been created. If I say kube control get deployments, I've got the example website deployment. It says I've got 3 of 3 replicas running. If I look in the default namespace, kube control get pods. Excellent. I've got 3 replicas of that container running. And you might be asking, well, how do you check? So right now, the website is not available on the internet. It's only available inside the cluster, and each pod has its own special IP. So if I say kube control get pods, and I want the output to be wide, we actually see the private IP address of each pod. So I've got 10, 20, 244, 011, 020, 124, 076. And so I want to just see if I can access the web page. And so what I'm going to do is I'm going to spin up a utilities pod. So this is a little pod that comes with a lot of Unix utilities pre-installed. Some people like to use BusyBox, and I think that's a great option. BusyBox doesn't come with curl pre-installed, and so I'm going to use a tool built by my friend Andy Suderman at Fairwinds called Utils. So I have the utils deployment actually all set up. And so let me just show you where this lives. So in GitHub, if I go to Suderman Jr. Utilities, this is just some information about the tool. And then there's two versions. There's just the regular utilities pod, and then there's the utilities pod with privileged access. I don't want that. So what I've done is I have just copied this into my my current project. So let me put this in the chat. Actually, I'm going to send it to the person helping me, and then they'll put it in the chat. So thank you, Polina. So I'm going to stop here, and it looks like the video quality is okay. For most people, I'm sorry for those of you for who it's not. And then GK asked a good question. They asked, how do you decide the number of pods? In this case, I just picked what I thought would be a good number. 3 seemed like a nice number that's good for reliability. So if 1 is down, there's still 2 pods available. If you're doing this in production, you could use data about traffic to decide that, or you could set up some auto scaling so that depending on how much maybe CPU or memory is being used in the pod, then you can scale up the number of replicas. But that's a good question, but I just chose 3 as a random number. So back to the cluster. So what I want to do is I want to see, do I have the example website available? Can I access it within the cluster? I have to create this utilities pod in order to do that, because I have to have something inside the cluster that can make the HTTP request. So, okay, I'm in the example website directory. I just went up 1 directory. I should see my utils YAML, and I'm going to say kube control, create the utils YAML. Okay, so I've got a deployment. I think it's just 1 pod. So kube control, get deployments, utilities. Yep, just 1 pod is all I asked for. And let's look at the control, get pods in the default namespace. Beautiful. So I have this utilities pod, and what I'm going to do is I'm going to exec into that pod and curl the IP address of one of these other pods. So I need to get those, kube control, get pods, output wide. I need that output wide so I can get an IP address. All right. So to exec into the utilities pod, I'm going to say kube control, exec, interactive terminal into this specific pod, and I'd like to use bash as the shell. Okay, looks like I'm in the utilities pod. Do I have curl available to me? Yep. Looks like it. And so what I'm hoping is that when I curl and send a GET request to this IP address, that I'll be able to see the HTML for that capybara page. So let's do curl. Oh, it says connection refused. It must need port, I think it was 3000. Hey, okay. So what I did is I just made a GET request to that IP address of that pod, asked for port 3000, and then you can see the HTML that I wrote. So hello, friends watching this DigitalOcean Tech Talk. There's the image tag. Oh, this must be an old version for a different talk. Oh, I just didn't change the alt tag. Oh, I've done this talk, a variation of this before, and I had a different picture. But to prove to you that that's the HTML that I wrote, if we go to the example website and we go to the public, here's that HTML. So this is great. I've got my code is running in a Kubernetes cluster. There's 3 replicas of it. But no one can access it. And so this is, or no one outside of the cluster can access it. And this is where a service comes in really handy. And so I am going to actually use my whiteboard now to draw something. So let me pull it up. So I've got, let's see, 1, 2, 3. So I've got, these are like, let's see, representing my, oh, this is harder than I always think it will be. These are my 3 Kubernetes nodes. And on the nodes, I have the website pods running, and maybe they're website. So I have 3 replicas running, and right now the only thing that can access those are inside the cluster. And so what I want to do is I'm going to create a Kubernetes service type called a load balancer. And so if this is the cluster itself, the load balancer is provided by the cloud provider, and it's actually going to give a way for the outside internet to access the code that's there so that you can see the Copybar website. So let's actually just do that now. So thank you. All right. All right, I see some questions. I'm going to show the load balancer and then I'll go back and answer those. Okay, so what do I want to do? I want to create a Kubernetes load balancer service type. And so let me close out some of these. And I'm going to close out this localhost one so I don't get confused. And I'm just going to Google Kubernetes Services. And this is a great part of the Kubernetes docs. It's called Connecting Applications with Services. And what I'm looking for is an example YAML file of a load balancer service. So let me, okay, exposing the service. So I just searched for load balancer. That looks like YAML, but it looks like it's just output. I want a manifest that I can use. So load balancer, load balancer, load balancer, load balancer. That didn't work the way I wanted to. So I'll stop that search and I'm just going to scroll. All right, so that's a deployment because of the kind. That's a deployment. Aha, okay. So here's a service. And this is a type node port. It's not quite what I'm looking for. I might just be able to borrow that though. Okay, this is a little bit simpler. So I have this YAML manifest. It's type service. It's got some metadata. It's got a spec. It's got a selector. It doesn't have the type on it, but we'll create that in just a second. So I'm just copying that to my clipboard. And I have a blank file here called service YAML. I'm going to paste that in. And so what I'm doing is I'm creating a new Kubernetes resource called a service, and I'm going to call it example service. And since this is a load balancer, I'm going to put LP at the end. And then the labels, I'm going to call it the same thing. Example service LB. Oh no, that's not right. So what I want is I want the service to be connected with my example website. And so the label here was app website. So I'm going to have the selector. I'm a little nervous about this run selector, but that's okay. So we'll do website. And so actually what I'm going to do is I'm just going to look at my solution from here just to make sure I'm good to go. So if I go to example website, I already have this set up. All right, so here, let's see, I can make this bigger. All right, I've got API version, I've got a service type. The service has a name. So it has the selector is with the app label and then the ports here. So let me actually go to raw. Let me grab that. And let me replace this here. Okay, so let's look through this. All right, so I've got a service kind, and it's going to be called example service since this is a load balancer. And then I'm saying I want the service to sit in front of and direct traffic to anything that has the label of app website. And we'll look at that in just a second. I want the traffic to be directed to port 80, but in the application itself, it's port 3000. And then this is important. You have to say the service type is load balancer. There are, I think, 4 different Kubernetes service types. The default is ClusterIP, which is what we'll be exploring next. So if you leave that blank, you're going to get a ClusterIP, but we want the load balancer so that our cloud provider can open up and direct traffic to the actual application. So let's take a look at our pods in the default namespace and just make sure that the label is there that we want. So if I say kube control get pods and I say show labels. Okay, so I have the example website pods, 3 of them, and I have the utilities pod, and I want the service to direct traffic to the example website pods. And the labels that they all share are this app equals website label. So I think we are good to go there. So let's make sure spec selector app equals website. Beautiful. So what we're going to do is I'll change back into the example website directory. And then I'm going to say kube control create whatever is in the kube manifest, the service YAML. Oh, I didn't say -f for that file. So let me add that. Oh, did I already create that? I mean, maybe when I was practicing. So let's see. So the error says that already exists. The example service LB already exists. So let me see kube control get services. Hey, and it looks like it does already exist. That's an old one. So what I'm going to do is I'm going to delete this. I'm going to make it again, and then we'll chat because it takes a little while. So I'm going to say kube control delete service, the example service LB. So let's go back up. Let's create that service. And then if you say kube control get services. Okay, so this is what I wanted to show you. I have my example service. This is the load balancer. And it's got an internal cluster IP, but what's happening now is under this external IP column, Kubernetes is working with DigitalOcean to set up a load balancer. All right. So Chen Hai says, would you be able to run the app directly on your local browser? So I showed you on my local machine that I could run the application, and you could, from the Kubernetes cluster, you can use a port forward to send the application to your local machine. So that's something you should check out. I would just Google kube control or Kubernetes port forward. Gabrielle asks, can any pod receive requests from every other pod inside the cluster? That's a very good question. Only if the pod has the ability to make HTTP requests. So I spun up that utilities pod. It has that tool curl in it, which can make requests. So if you create a container that doesn't have that functionality in it, then you're going to be hard pressed. So that's where you start like thinking about writing an application and how will it communicate with the other applications. Later on in the talk, when we go over ClusterIP, we'll see a little bit of what that looks like. Nathan asks, how should namespaces be established and managed in Kubernetes? It's a pretty open-ended question, in my humble opinion, just curious. It's a great question. Namespaces are, groupings, and you can make it so that things that are in one namespace can't access things in the other. So the good thing is that it's really easy to make a namespace. So if you say kube control, create NS for namespace, and then like test namespace. And if you say kube control get namespaces, you can see I have what is that, 4 that come with Kubernetes, the default, kube node lease, kube public, kube system, and then I made my own. So it's kind of up to you and your engineering team, but I would just play with it. So Rick asked, Kim, are the pods accessible within the local machine? That's related to Chen Hai's question. If you use the port forward command, you would be able to look at the pods locally. Jimmy asked a good question. So he says, I am trying to follow along, but I'm getting a 401 when trying to pull your image. So my image is private. And so I would recommend you like build that image on your own machine and push it to a container registry and maybe try it that way. But right now, all the images I'm using here are private, and they're only accessible in my DigitalOcean Kubernetes cluster. And then it looks like I made some typos. Let's see. All right. And then Gabrielle says, I mean, is there any type of firewall between pods, or is traffic open to every pod in the cluster? That's a great question. The load balancer that we're creating means that anyone can access the external IP and access the pods. So there are ways of using like ingresses or firewalls to set up better security. So yeah, this is not a very secure example, but just an example to show you how do you get something accessible on the internet. All right, so let's clear this, and I'm going to look at the services again. All right, so in my example service for a load balancer, I have both an IP address, that's a cluster IP, and now I have this external IP address. And so I'm really excited to see if I hit this external IP address, will I see that capybara page? Hey, hey, hey. So if you're watching this live and you go to that IP address, you should also be able to see this page. I'm going to pull down this cluster as soon as the talk is done. So if you're watching the recording, it shouldn't be available. But this is so cool. So now this HTML page is getting served up from one of the 3 pods that's in my Kubernetes cluster. And this is the example of the service type load balancer. DigitalOcean's load balancer has opened up ingress, and now I can access those pods through that IP address. So I just think that's like the coolest thing ever. So if you're at home and you want to try that, you can hit that IP address there. So let's go back and take a look. All right, so I just did a lot of things. So the last section was a demonstration of the load balancer service type. And so I showed you the example website where I had it running on my local machine. Then I deployed the example website as 3 different pods in my Kubernetes cluster. And I was able to access them internally within the cluster using that utilities pod. And then I used a Kubernetes load balancer service type to actually expose the application to the internet. So that is the load balancer service type. I made that the first thing that I was going to demo because I think it's the most powerful and the most important one. But that is the load balancer demo. And it looks like, people are answering each other's questions in the chat. So I'm just going to move on. All right, so that was the load balancer demo. And now what I want to do is I want to show you how the cluster IP service type works. And the way that I'm going to do that is with a little project I call Example API. And I'm going to go through a very similar flow where I show you what the API looks like locally on my machine. I'm going to deploy it into the cluster, and then we're going to access the Example API just internally. And we're not going to expose this endpoint to the internet. So. All right, so I'm in my example website directory. If I go up one and then change into my API directory. So this is a simple, it's not even a REST API. I guess it's REST, but it's just an API that accepts GET requests. And so it was written in Go. And so if I say go run main.go, this one is on port 4000. Whoops. Wrong browser. So let's see, where did my browser go? Nope, that's not it. Oh, geez. This is always embarrassing. I think it's because I'm full screen. So I say a local host 4000, it says there's nothing found here. And since this is an API, I have API version 1, and if I ask for users, I get a list of some user data. And these are some of the developer advocates at DigitalOcean: me, Mason, Chris, and Matt. So this is just data for you. And there are some other endpoints you can hit, like you say user, and then the person's specific name, you get a JSON object of just their data. And so I want you to imagine that you have this API and it's got data that other applications are going to consume, but you don't want this available to the public. This is only something you want available to other applications in your Kubernetes cluster. So I'm running this locally now. Well, that's not what I wanted. Let me kill this process, maybe. Oh my gosh. Sometimes when you're doing things live, you forget how to type. So let's see. Control-C, there we go. So if I look at this, so that's example website. Now I'm in API. In kubemanifest, same thing. I have a deployment here. I'm going to create 3 replicas of this API running in my Kubernetes cluster. I've got the image down here, and the label I'm giving it is app API. So if I say kubecontrol create from the file kubemanifest deploy.com, let's see what the Kubernetes API says. It says, hey, I created that deployment for you. If I get my deployments, I have the utilities deployment, the example website deployment, and now I have the example API deployment. It's just 6 seconds old. If I say kubecontrol get pods, I've got, they're very new, they're 19 seconds old. I have 3 pods running with the example API, and that's very cool. So let's do the same thing. Let's open up a utilities pod and make a request and see if we can access that data we saw in my browser. So first thing I'm going to do is I'm going to say get pods. I'm going to say I would like the output to be wide. And actually, let me grep API. That's beautiful, but let me do it this way. Okay, so you can just see the API pods. Beautiful, except now I need the utilities pod named utilities. Okay. So I'm going to exec back into this pod. I should have done that in a different tab and just kept it open, but that's okay. So kubecontrol exec to an interactive terminal into this pod, bin bash. If there's a Kubernetes command you might memorize, that exec one is a good one. All right, so I'm in the utilities pod, and I want to curl and see the data in one of these pods, the example API. So grab this. I'll say curl here, and then I believe it is port 4000. And then I need API v1 and then users. And I like the utilities pod because it has JQ in it, so I can format my JSON. Okay, so this is my API code. It's in the Kubernetes cluster, and I can access it from the utilities pod. But let me exit out of this. What I want is if I want my example website to be able to do something with this data, it has to be able to communicate with these example API pods. And so this is a great opportunity for the ClusterIP service. So ClusterIP, I'll get back the whiteboard. So for the load balancer service type, I was able to have the cloud provider use their load balancer and then direct traffic to my pods. And now what I want just pods inside the Kubernetes cluster to be able to access other pods inside the Kubernetes cluster. But like I said earlier, those pods, they get spun up and they get torn down a lot. That's just the nature of Kubernetes, these immutable objects. And so I don't want to have to hard code that pod IP address like I just did with the curl command. I want to be able to ask for the service specifically. And so if we go back, I have that blank service manifest, and I'm going to just copy the YAML from here and paste it here. And so there are some things we need to change. So the first thing is, since this isn't a load balancer service, we'll change this to cluster IP service, and then the selector, I want the pods that have the app, I assume it's API. Let's see. Yep. So I want the selector to be API, WAPI. Ooh, that's a cool looking word. API. And then the port is just going to be 80, and then the target port is 4000. And instead of type load balancer cluster, we're going to do type ClusterIP. All right, so if you remember from my first service example, I already had one running because I practiced this talk. So what I'm going to do is I'm going to delete the service called example. Oh no, example service ClusterIP. Okay, so you can pretend that never happened. Control get services. So I have my load balancer service with that external IP. I already have a ClusterIP service running called Kubernetes, and now I'm going to create a new one called example service ClusterIP. So I'm going to say kubectl create from the file kubemanifest service.yaml. And it says, hey, I have created that ClusterIP service. Let's see. So that service has an IP address that's private within the cluster only. There's no external IP. And so let's go back to the utilities pod and let's curl that and see if we get that data. Let's see, just going up. Okay, let's do a reverse. Oh, maybe, there it is, okay. So there's that command. I'm back in my utilities pod. And if I curl the IP of the service, and I think it needs to be API v1 users. And if I got it right, maybe we can format the JSON output. Hey, that's so cool. Okay, so I'm getting the data back. Instead of querying the specific pod IP address, I was just querying the IP address, excuse me, of the service. And so that's really nice. So if I know the IP address of the service, then I can get the data, and I don't know what pod it's from, but all the pods are running a replica of the same thing. So that's pretty nifty. There's one thing I want to show you, which I think is super cool. And it is Kubernetes service discovery. And so if you have services running, you don't actually even need to know the IP address of the service to get the data. You actually just need to know the service name and the namespace that it's in, and then what kind of thing you're querying. So this is the template that shows you if you're using the service discovery DNS thing instead of the IP address, you say the service name and then a dot, and then the namespace, and then a dot, and then SVC for service, and then a dot, and then cluster and local. And so for the thing that I am doing right now, I'm going to find the service name, which is example service cluster IP, and then I'm in the default namespace, and I'm looking for a service, and then I'm in the local cluster. So let's curl that instead. Isn't that, Noah? Isn't that service discovery syntax like super amazing? I totally agree. Noah's in the chat. Okay, so I'm going to say curl. And instead of the IP address, I'm saying, I got to remember, let's see. Sample-service-cluster-IP. Okay. Why don't I just copy this? Whoop. Okay, copy. And all right, let's see what we got. Oh, it says 404 page not found. That's actually the response from my API. I forgot to add the endpoint, which is API v1 users. Hey, there's my data. And if I wanted to format it, I could use JQ. But yes, the service discovery syntax is so cool. And in my specific case, I don't even have to have all of this stuff at the end of the default service cluster, since I'm already I'm in the default namespace. So if I just use this endpoint, I should be able to get my data. So example service cluster IP. So curl example service cluster IP, API v1, if I say user and then my name, and then I pipe that to JQ, hey, that is that data from my API. And I'm not hitting a specific pod because the pods come and go, but I'm hitting the service endpoint itself. And I'm not actually even hitting a specific service IP address in the cluster. I'm just using that service discovery to find the service and grab the data from one of those replicas. So I hope that this helped you see like some of the power of this Kubernetes service discovery feature, where if you know the name of your service, you can query that and the service can come and go, the IP address can change, the IP address of the pods can change, and you get all of this power there. So let me go back to my presentation and see where we're at, and I'll look at some questions. So that was the ClusterIP demo. So we'll go over this a few times, but a ClusterIP service only enables communication inside the cluster. And in the example that I showed, I have an API that serves up data about users that other applications in the cluster might use, but you don't want anyone on the internet to access that directly. And so that's a good use case for the ClusterIP. And so I'm going to look at some questions, and then we're going to go back and look at some of the definitions and compare the different service types now that we've got some concrete examples. So let's see, scrolling up. All right, let's start with Gabrielle. Let's see, had a question. They said, so if we want to curl a pod in another namespace, do we need to make a request to the ClusterIP service because traffic isn't allowed between different namespaces? That's a good question. So you could, if you were just like working in your cluster, you could get the names of the pods and do the output wide and get the IP addresses of the pods and then do that directly. But definitely, I would say using that service discovery or using the IP address of the ClusterIP service would be the best way to do that, so you don't have to worry about namespaces. Chen Hai says, is the load balancer deployed on the cloud provider or on your local Kubernetes so everyone on the internet can access it? So the load balancer, there's a lot of magic going on behind the scenes. And so by enabling the load balancer type service, I am then asking DigitalOcean, like, hey, will you please spin up one of your load balancers? And then when traffic is sent to that IP address, you're going to load balance across the pods. So it's cloud provider specific. AWS has their own load balancers. Google Cloud has their own load balancers. Azure, Vultr, everybody. And so at the very beginning, when I recommended not using Kind or another tool to run Kubernetes locally, it was so that you could see the power of the load balancer. I bet there's ways to emulate that in Kind, but I don't know what they are off the top of my head. Yes, there's a lot more about load balancers that I just don't know the details of off the top of my head. So let's go to James. So James says, hi, I enjoy your products. How would I push an image from a private Docker Hub repo to your Kubernetes platform? Do I use secrets? I guess it depends on the container registry that you're using. And so in DigitalOcean, if you're using DigitalOcean Kubernetes and the DigitalOcean container registry, there's a setting in the container registry where you can say, allow these images to be pushed and pulled by a DigitalOcean Kubernetes offering. In terms of the other, like if you had an image, a private image on Quay or Docker Hub, I don't know the answer off the top of my head, but it might involve secrets. Let's see, Noah asked, is there a function like kube control port forward, but for cluster IPs rather than internal pod IPs? That's a really good question. So I think what you're asking is, can you like port forward a cluster IP service so that if I open up my browser and I'm like hitting an endpoint, it'll direct traffic to one of the pods. I think the port forward syntax handles that for you. So I would just look at kubectl port forward. But I don't know the answer to that off the top of my head. And then Sabin says, does ClusterIP forward traffic to pods in round robin only? That's a great question. I think it is round robin. I'm not sure how much control you have over that. So one of the things we'll talk about at the end are like some more advanced things or some more things to look at. And I recommend looking at different ingress types like ingress nginx, because you can have more power over the algorithm that the load balancer is using. And then Rick says, how can we achieve cluster to cluster communication? That's tricky. The way that I've done it in the past is I've had like 2 different clusters in 2 different virtual private clouds, VPCs, and then peered the VPCs. So that's one way you can do it. But that is tricky for sure. And then Itopa asked a very similar question or made a comment. Is it effective to have clusters communicate amongst themselves by having them in a VPC? You could do 2 clusters in a VPC and have them communicate that way. So that's a good question. All right, we're getting toward the end. So I showed you an example of the load balancer service, an example of the ClusterIP. Let's actually dig into the definitions of different Kubernetes service types. And so I have this table here, and there are 4 different Kubernetes service types. The first one that we looked at was the load balancer, and that's where the service is exposed through the cloud provider's load balancer. And that's how you can get external traffic to access your Kubernetes pods. The other service type that we looked at is ClusterIP. That creates a service that's only available in the cluster. So that's if you have a workload that needs to give data or communicate with other workloads in your cluster, but you don't want people from the outside to access that. There are 2 other service types that I didn't cover. The first one is node port. Node port is when you have your secondary nodes in Kubernetes and you actually expose a specific port on a specific node. I guess Kubernetes load balancers are actually a node port underneath all of the abstraction, but node ports I didn't cover because like pods, nodes should be able to be created and taken down kind of whenever. And so you don't want to be beholden to a specific IP address of the node or a specific port on that specific node. And then the next one, which is something I think you should explore, and maybe I'll explore later, is external name. So what that does is it maps a service to a domain via a CNAME record. And so if I wanted to, instead of saying, hey, go to this IP address, which is really weird, especially if you have customers, and you'd say like, oh, I go to hellocapybara.com. An external name service is how you would link your domain with the actual Kubernetes service. So. All right, so just so you know, I didn't cover node port or external name, something for you to look at. Load balancer and ClusterIP services, I think, are the coolest. So let's hop into the recap. So a Kubernetes service allows you to access a pod without needing to know the pod's IP address. And one of the powerful things about Kubernetes and just the way that we run digital infrastructure now are these like immutable objects, things that can be spun up and torn down, and you shouldn't have to worry about specific IP addresses. And so a service sits in front of a set of pods and directs traffic to those pods. Your service has to be connected to the pods through that label, like we had app equals website or app equals API. But it's a way for you to harness the power of those immutable objects. There are 4 different types of Kubernetes services. We only covered ClusterIP and load balancer. And then the coolest part is service discovery, where you don't even need to know the IP address of the service. If you just know the service name, you can sort of plug it into this little URI formula where you say the service name and then the namespace that it's in. And then if it's service cluster local. So if this was you already knew all this information, or you really enjoyed this and you are looking to learn more, I would suggest next steps, explore the external name service type. And then more importantly, learn about ingress. So ingress objects and ingress controllers can do everything that a load balancer can do, or can be connected with a load balancer, but they have so much more power. You can route traffic via paths. So if a customer is asking for like, hey, I want to log in, or hey, I want to see my page, ingress controllers can handle that. You can, they're just really nice. So Ingress Nginx is a great open source tool for that. Ambassador Labs has a good Ingress. That there's an open source version and a paid version, but something to explore. That'll get you to more advanced Kubernetes usage. And last thing is, I would like to know, if you're watching this live, what's one thing you learned, or what's one thing you'll do differently after watching this talk, and to give you a little bit of time to think about that and to respond. So when I was preparing this talk, I knew about Kubernetes service discovery, and I had used it in sort of a secondary sort of way where I was just copying and pasting stuff. But for me, like knowing about the service discovery feature and knowing about how to specify which service I'm querying, that is the big thing that I learned. And if I'm working in a production cluster ever again, that's something I'll do. Yeah, let me know what's one thing you learned, what's one thing you'll do differently after your talk. Oh, Dana, yes, that utils image is so helpful. It's like BusyBox. It's got just a lot of great stuff in it where you can do sort of sys administration tasks by execing into that pod. Selva Balgia says service discovery feature was great. Andrea says, I have found it way more effortless to create a single source of truth for exposing services. I like that phrase. I hadn't used that. A service gives you a single source of truth for how to direct traffic to pods. Russell says, would love to know costs. If you go to just DigitalOcean.com and find our Kubernetes page, we're very transparent about pricing. So you'll see it there. And then last one, Rick says, what I learned is that my legacy app can use Kubernetes and definitely would use Kubernetes on my solution going forward. Very cool. Okay, one more. Joe says, the flag -- labels is a neat param that I either never knew about or forgot about. Yeah. If you want a little bit more information about the object that you're looking at, if you use show labels, it'll show you the labels. So, oh, Noah doing the work for me. Thank you. So Noah just added some information that a 2-node Kubernetes cluster with a load balancer is about $30 a month on DigitalOcean Kubernetes. So yeah, we're really proud of our transparency in pricing. And so take a look at our page, or if you've got an account, we'll tell you what your estimated monthly spend is. So, some resources. This is part of the slide deck, which we'll share, but there's the example Kubernetes workloads repo that I've made. I was inspired to give this talk by another DigitalOcean talk by 2 of the engineers who work on DOKS, Timo and Varsha. But this is a tech talk they gave about networking best practices. If you want to watch this, they'll talk specifically about DOKS and some of the networking things that happen without us knowing it, as well as the different service types that we covered. This is a link to the Kubernetes documentation, which is great. It'll give you some practice exposing an app. We've got a curriculum and ebook called Kubernetes for Full Stack Developers that you can find. And then if you're using DigitalOcean Kubernetes, we've got docs and quick starts. So, well, thank you everybody for joining me. Thank you for all the engagement in chat. We have other Kubernetes talks this week. If you you're watching, let's see, actually, DOCO-Tech Talks. So Well, maybe, yeah, I guess they are this week. So on September 27th, maybe that's next week, depending on how you count it, we have Introduction to Kubernetes Patterns, Scaling Your App with Repeatable Architecture. That's Saurabh Gupta. He is a wonderful presenter on Kubernetes. And then we have another talk called Kubernetes Starter Kit for Simplifying Day 2 Operations. So that's Sachin and Bikram. And I like this talk because Bikram's put together a set of tutorials where if you already know how to set up a Kubernetes cluster and you sort of know these basics, like how do you get to day 2 operations where you're actually like running your app securely and you're using ingress and maybe you're making backups of your cluster. So take a look at those. Again, thank you so much. My name is Kim Schlesinger, and I'll see you next time. Bye.